Okay, so today we're talking about the greatest common factor is the section 1.3 in your textbooks. Hopefully this is going to be a review. If not, that's what I'm here for. So here we go. First of all, greatest common factor. Let's translate this into plain regular English. Greatest means biggest. Common means they both have it. Factor is a number that you are dividing by. So, greatest common factor is the biggest number you can divide both numbers by evenly. I'll say that again. The biggest number you can divide both numbers by evenly. For example, I'm going to find the greatest common factor of 45 and 60. So, if you're very intuitive, you might already know the answer to this. If not, I'm going to go through the motions of how to do it using prime factorization. Now, prime factorization is the factor trees that you've done probably for the last 4 years or so. I'm going to see what I can divide 45 by. I know I can divide 45 by 5. 45 divided by 5 will give me 9. 5 is a prime number. I'm going to circle it. And then I can break 9 down into 3 times 3. These 3's are prime numbers. So 45 is 3 times 3 times 3. Then I'm going to do the same thing to 60. 60 ends with a 0. That means I automatically can divide it by 10. And it's going to give me 6 times 10 is 60. Neither one of them is prime because I can divide them some more. I can do 6 as 2 times 3. 2 is a prime number. 3 is a prime number. And I can do 10 as 2 times 5. And 2 is a prime number. And 5 is a prime number. So then I will rewrite 60 is the same as 2. And I'm going to write them from smallest numbers to biggest. 2 times 2 times 3 times 5. So I just basically write all of my circled numbers in a row. Next, I want to see what factors here I have in common. Well, 60 has 2 2's, a 3, and a 5, and 45 has, I made a boo-boo here, this is supposed to be 5. 45 has 3, a 3, and a 5. So I want you to see what do they have in common. 45 doesn't have any 2's, so they're automatically out. 45 has 2 3's, but 60 only has 1. So they only have 1 3 in common. And 45 has a 5 and 60 has a 5. So this is what they have in common. 3 and a 5. 1 3, 1 5. So I'm going to do 3 times 5 and get 15. That's my greatest common factor of 45 and 60. I can divide 45 by 15 and get 3. And I can divide 60 by 15 and get 4. 15 is the biggest number I can divide both of them by. Now, try finding the greatest common factor of these two numbers on your own using prime factorization like I showed you. So, let's do the prime factorization here together. So, let's break down 14. We know that 14 is divisible by 2, which is a prime number, and you get 7, which is also a prime number. 49, I know that 7 times 7 is 49. They're both prime numbers. Now let's see, what do they have in common? So 49 doesn't have any 2's, that's out. And 14 only has 1 7, so only 1 7 is in common. So the greatest common factor of these two numbers is 7. I can use greatest common factor to reduce a fraction. So first I need to know what that greatest common factor is between the numerator and the denominator. So I can do prime factorization for 14 and for 42. I'm going to break down 14. We just did it on the last slide. That's 7 times 2. Both of them are prime. And then 42, I can divide it by 7. So it's 6 times 7. 7 is prime. And then I can break 6 down into 2 times 3. 2 is prime and 3 is prime. So let's see. 14 has 1 7. 42 has 1 7, so that's a keeper. 14 has a 2, 42 has a 2, that's a keeper. 42 has a 3, but 14 does not, so I don't want that. 7 times 2 is 14, so that's the greatest common factor between 14 and 42. What I can do next is I can divide both top and bottom by 14. 14 divided by 14 gives me 1, and 42 divided by 14 gives me, what is it going to be, 3. So you can do it long division way, so 42 divided by 14, and you can try 3. So 3 times 4 is 12. So 2, carry the 1. 3 times 1 is 3, plus 1 is 4, divides evenly. So this is a reduced form of this fraction right here. All right, you can also use, and there we go. You can also use repeated division to reduce a fraction. So if you don't feel like dealing with a factor tree, what you can do is think, okay, so just any old number that I can divide 14 and 42 by. They're both even, I can divide both of them by 2. And what I end with is 14 divided by 2 is 7, and 42 divided by 2 is 21. Again, you can do it long ways if you're more comfortable that way. And then I'm going to see, is there another number that I can divide both 7 and 21 by? Well, I know that 21 divided by 7 is 3. So I can divide both of them by 7. And 7 divided by 7 is 1, and 21 divided by 7 is 3. So you see how I got the same exact answer. So if you don't feel like dealing with factor trees or big numbers, this is a way to go for you. So now I would like you to use either method to reduce this fraction on your own, and then push play to check your answer. Okay, so first, I can do prime factorization, so I can do 72 and 96. So I'm going to do it this way first to show you. So 72, I know 72 is 8 times 9. I can break down 8 some more into 2 and 4. 2 is my first prime number that I got, and then 4 is 2 times 2. And then 9 is 3 times 3, and I'm circling all the prime numbers. Then I know I can divide 96 by 2, and I will get 48. I can divide 48 by, let's go with 6 times 8. Neither one of them is prime. I'm going to go further, 3 times 2, and 2 times 4, and some more, 2 times 2 for the 4. Now, I'm going to see what I have in common. So 72 is 2 times 2 times 2 times 3 times 3. 96 is 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 of them, times 3. Let's see what I have in common. This has 1, 2, 3 2's. This has 1, 2, 3, 4, 5. So I can only keep 3 of them. So I'm going to get rid of the other 2. This has 2 3's. This has 1 3. So I can only keep one of these 3's. So 2 times 2 is 4. Times 2 is 8. 3 times 8 is 24. So 24 is my greatest common factor. So 72 divided by 24, and then 96 divided by 24. So 72 divided by 24 is 3, and 96 divided by 24 is 4. So there you go. So this is 3 over 4. Now, you can also do repeated division. So I have 72 over 96. I can divide, since they're both even, I can divide both of them by 2. So 72 divided by 2 will give me 36. 96 divided by 2 will give me 48. I can keep going. 36 divided by 2 will give me 18. 48 divided by 2 will give me 24. I can divide it by 2 again. Oops. 18 divided by 2 will give me 9. 24 divided by 2 will give me 12. Now, I know that I can divide 9 and 12 by 3. And 9 divided by 3 gives me 3. 12 divided by 3 gives me 4. I get the same answer. All right, how do we write decimals as fractions? I'm going to use pretty similar approach here as part of it. So first of all, I'm going to sand my whole number to wait for me ahead of time. And then I'm going to write the decimal part as I'm going to take what my non-zero number is, which is 8, and write it over 1 with as many zeros as there are decimal places. So this is going to give me 1,000 because 3 decimal places, 3 zeros. After that, I can reduce it. I'm going to use continuous division. I think that's what I called it. So I know I can divide 8 by 4, and I know that I can divide 1,000 by 4. So 8 divided by 4 gives me 2. 1,000 divided by 4 will give me 250. And I know I can divide both of these by 2 because they're both even. 2 divided by 2 is 1. And 250 divided by 2, if you need to, you can go and do it on the side. So 5 divided by 2 will give me 2. And then minus 4, bring down another 0. That's a 5. So 1 over 125. So try writing this decimal as a fraction on your own and then go back and check your answer. So let's see if you got this right. So just like in the previous problem, we don't have a whole number here, but we do have a negative. So this negative is going to wait for us ahead of time. And then I'm going to write the non-zero part of my decimal, which is 35. Over 1 with as many zeros as decimal places. So it's 1 with 2 zeros, which is 100. Then I need to reduce it. So I know that 35 ends with 5, 100 ends with 0. Both are divisible by 5. So I'm going to divide both top and bottom by 5. You can choose with greatest common factor. I personally just like this way better. So 35 divided by 5 will give me 7. And 100 divided by 5 will give me 20. Now, 7 and 20 cannot be divided by the same number anymore. So, not evenly. So, that's the end of it. This is my answer. So, if you are confused on any of this, go back, watch it again, pause it when you need to, rewind when you need to, and just make sure that your note sheet is filled out, it's signed, and you bring it back to class tomorrow, and I'll answer any questions you have. Okay, I'll see you tomorrow.